Hi, ladies and gentlemen. This is Mr. Green, and this is another in my lessons on Algebra 1. We're looking at a lesson that deals with uh, what happens when we complicate our algebraic expressions, our equations. What happens when we put variables on both sides of the equal sign? Okay? So we're just looking at more tools that we're going to use to solve algebraic equations and capture the relationship between things and hopefully make you realize that some of these are real world situations. They do occur. If I put the variable on both sides of an equation here, what we want to do is we want to make certain we get those variables together. So we want to make certain we get the x's on both sides. So instead of starting with the constant, the number, I'm going to start with the variable. I'm going to pick the smaller of the two variables. Why? Because I don't like dealing with negatives. Okay? I don't like dealing with negatives, and so what I'm going to do is I'm going to start with that variable. I'm going to subtract 2x from both sides of the equation. I picked the smaller of the two sets of variables and subtracted it. That way I won't get a negative number. So 2x minus 2x is 0, so I'm going to get a negative 7 here. Okay? And 3x minus 2x is x, so I'm going to get x plus 5. Now I'm going to look at the number, the constant here. I'm going to subtract the 5 from both sides of the equation. X plus 5 minus 5 gives me x. Minus 7 minus 5 gives me a minus 12. So what have I got? X equals minus 12. I want to check it to make certain it works. I'm going to say 3 times minus 12, stick the value in there, plus 5. Is that equal to 2 times minus 12? Minus 7. Well, 3 times minus 12, that's negative 36. And adding 5 to that, negative 36 plus 5 is negative 31. 2 times negative 12 is negative 24. And subtracting 7 from that is negative 31. They're equal to each other. It's true. Check. I checked it out. My answer is not 31. My answer is right here. X equals 12, negative 12. I was checking my work down here. So let's see what happens if we do another one of these. We're going to try to maintain that we've got things on both sides of the equation, right? So this is what I'm given. First thing I'm going to do is I'm going to look at the variable. I see 2x, and 2x is smaller than 5x, so I'm going to subtract 2x from both sides of this equation. I'm going to get 3x plus 2 equals 14. I'm going to subtract 2 from both sides of this equation. And I'm going to get 3x equals 12. Now I'm going to multiply times the reciprocal of 3, which is 1/3. And when I do that, what I'm going to wind up with is x. And over here, I'm going to get equal to 4. So x equals 4, right? I want to check it. 5 times 4 plus 2, that's 20 plus 2, that's 22. And over here, 2 times 4 plus 14, that's 8 plus 14, that's 22. I got 22 is equal to 22. That's correct. That checks. And so my answer would be x equals 4. And I checked it by saying 22 is equal to 22. Okay? Notice, everything I did to one side of the equation, I did to the other side of the equation. Kept it balanced. Solved it for x's. Okay? Let's try it again. Here I've got equation, right? I've got x's on both sides. I'm looking at it. I see 4x over here and I see 5x over here. 4 is smaller. I'm going to subtract 4x from both sides of this equation. And what am I going to get? I'm going to get x minus 5 equals negative 3. I'm going to add 5 to both sides of this equation. And I'm going to get x equals 2. Ta-da. There's my answer. I want to check and make certain it's right. So I'm going to say 5 times 2 minus 5. That's 10 minus 5. That's 5. Is that equal to 4 times 2 minus 3? Well, that's 8 minus 3. That's 5. Ta-da, they equaled each other. Check. So my answer is x is equal to 2. That's the way you solve these problems when you have x's on both sides of the equation. Ha ha ha. Wouldn't it be more efficient just to ask who's complicating the equations and ask them to stop? Well, yeah, but you know what? Sometimes these things just occur naturally, and there's not a lot we can do. I want you to see what this professor has got up here on the board. Okay? This problem here, distributive property. 4 times 1 is 4. 4 times minus x is minus 4x. 3 times x is 3x. 3 times 1 is a 3. Minus 2 gives you the 1. Ah, that's what he did. Now, I've got a 4x and a 3x. And you go, well, 3x is smaller. Why didn't he subtract it? It was the 4x is a negative 4x or minus 4x. Therefore, that's the smaller one. So I want to add 4x to both sides of the equation. And I wind up with 4 is equal to 7x plus 1. Subtracting the 1, I get 7x is or 3 is equal to 7x. Dividing by 7 in this situation, we get that x is equal to 3 over 7. Ta-da. That's the answer to this problem. Cool? And while we might agree with this kid right here, that's not the problems that we're going to be facing. A lot of times in nature, a lot of times in natural situations, these things occur and we cannot help it. Okay, solving some of these problems, you might run into something you don't recognize. You might have a problem that you don't know how to solve. Make certain you're doing the offline work and checking your answers with the information that is in the student guides in that area. Make certain you're getting these things taken care of. If you have questions, if you have things you don't know how to work, make certain you're bringing them to either tutoring or you're bringing them to Class Connect so that we can solve them. Okay? I look forward to hearing from you next time.